Another violation of the second OLS assumption, which may affect the internal validity of our model, is correlated errors. So correlated errors can come about, for example, because we have a time series model in which we have time here and we have the y variable here, maybe a price or GDP or something else, and we observe this process over time. And often, very often, these models create or suffer from correlated errors. That the correlation between the residual at time t and the residual at time t minus 1 is different from 0. That you have some kind of autocorrelation in your model, and this can easily be detected by actually checking the residual or the residuals for this autocorrelation. Another situation in which the error terms are correlated could be when sampling is based on geographical units. For example, you're trying to model the GDP of a country, but suddenly the country next door or the neighboring country suffers from a political crisis, which affects the GDP growth in your country, which you are trying to model, the GDP growth, and this political unrest might drag on for several quarters or even years, which may induce correlated errors in your model. So, what is the effect of correlated errors? It's actually not that big effect on the OLS estimators, the betas, and they are still non-biased and consistent, which means that on average they hit the true beta, the true intercept, and the true slope, but it does result in inconsistent standard errors, just as heteroscedasticity. So the solution for this is to obtain a truly random sample. But in most cases, this is not possible. And in that case, you can use something called cluster robust standard errors. And we are going to discuss this further in later classes.